So to begin, my name is Lisa, and I'm going to be leading this workshop. We're going to be talking about data analysis and visualization, and this is CLE credit, and we will have their QR code for that attendance at the end of the slides. So before we get started, I am a senior here at UNC. I'm studying biostatistics, and with Journey, I am a social science editor. And then we can go to the next slide. So as an overview, here are some of the things we're going to cover today. First, I'm going to introduce what data analysis and visualization is for your research. Then we can go over some fundamentals of data analysis and how you can analyze data for your research. Next, we'll talk about some visualization principles, why it matters, some common types and principles to look over. Then we'll talk about applying these skills for your research paper and how it can fit into a manuscript. Then we'll end with a quick tutorial on Google Sheets for simple data analysis, and then we'll have time for questions at the end. Okay, so what is data analysis and visualization? When you're conducting your research, data analysis consists of three main steps. First, you're going to want to clean your data. This looks like valuing your data and handling any missing or incorrect values. For example, if you're collecting blood pressure data, you want to make sure that you don't have absurd impossible values like 1,000. And if you're using survey responses, you want to make sure you're handling people who didn't fill in certain questions and how you want to address those issues. The next stage involves summarizing and analyzing your data. This looks like conducting simple statistics and performing statistical tests to explore your research questions or test different hypotheses. And then the last main part of this is visualizations. These are tools that you're going to use to condense the results from your data analysis. And this will allow you to communicate your evidence in easily interpretable format like tables, plots, and graphs. Okay, so before diving into data analysis and creating your visuals, we want to make sure that you are developing a well-formulated research question. This question will guide your data collection process, what analytical methods to use, and how to present and interpret your methods or your results. For example, take the question, does age affect health? This question does not guide your data collection process. It's too broad and lacks focus and does not provide a clear, measurable measure of health. A better alternative would be, how does age influence systolic blood pressure levels? This question is specific, measurable, and can directly guide what data you want to collect and how to analyze it. So your data analysis is entirely dependent on the types of data you collect and the type of structures this data might come into. So the two main types of data are quantitative and qualitative. Quantitative data refers to numerical data, and this can be split into either continuous or discrete. Continuous data takes on a wide range of value. For example, your weight, you can weigh 130, 130.1, 130.2. And then there's discrete numerical data, which is like an example would be number of patients. You can have 1, 2, 3, 4, 5, but you can't have 3.5 patients. And then the next main type of data is qualitative or categorical. This is type of data that can be split into different categories, and this can either be nominal or ordinal. Nominal data is like blood type. You can have type A, type B, type O, but within those categories, there's not any specific order. And then ordinal data is also split into categories, but there is an inherent order, such as pain level. You can order this by mild, moderate, or severe pain level. And then your data can either come in structured or unstructured formats. A structured data set would look like some records of defined fields, spreadsheet, or different databases. It usually comes into a table that you can download into software you're using to analyze. And then unstructured data looks like free form, not really organized into a set base. And this usually looks like analyzing different survey responses, medical notes, or maybe you have access to a variety of audio transcripts. Next, we'll be going over common data analysis methods that we can be using with different data types. First things first, regardless of the type of analysis you are conducting in your research, it is important to summarize the data you collected and describe any patterns. Some common methods to consider are calculating a central tendency measure and a variability measure for numerical variables. For example, you can calculate the mean and standard deviation for the systolic blood pressures you calculated in all the patients you studied. For if you collected categorical or qualitative variables, a better measure would be to calculate frequency distributions or frequency counts. For example, you can report how many of the people you studied were males or how many were females. And then lastly, it is common practice to report correlation between any variables of interest. However, when you're reporting this correlation, it is important to remember that correlation does not equal causation. Correlation is only a form of association. So next we'll be going over some common inferential tools. These are tools used to make inferences on a larger population. So first we can talk about hypothesis testing, which is a statistical method that describes whether the patterns you observed in your study or research are due to data or are due to real effect or due to chance. Some common tests are t-tests, which are used to compare the means between two different groups. ANOVA is kind of an extension of a t-test, which is used to compare the means between multiple groups or more than two groups. And then we have chi-square test, which is used to compare categorical variables between two different groups. So we can look at this example. In this case, we want to test whether caffeine improves students' reaction time. So the null hypothesis in this case would be that caffeine has no impact. Like I said before, we want to observe patterns that are due to chance, or we're observing whether your data is due to chance or due to an effect. So your null hypothesis will always be no difference or no impact. So using a t-test, it would plot the distribution of reaction time in students, assuming that caffeine has no effect. And using your data, the test determines the probability of observing the data that or the mean that you collection or higher, and this is known as a p-value. The smaller your p-value, the less likely it is that you compute the value you found, providing some evidence against the null hypothesis. So a common cutoff value for the p-value is less than 0.05. If you find a p-value less than 0.05, this usually leads you to reject the null hypothesis, and if your p-value is greater, then you fail to reject the null hypothesis. Another common method when analyzing relationships between variables is regression. Regression can be used to explore relationships based on previous scientific knowledge. For example, does physical activity influence the risk of heart disease? Regression can also be used as a prediction tool. For example, you can use your data to model collected students' GPA against the times they reported they studied, and linear regression will create a formula that predicts students' GPA based on their study hours. And then lastly, regression can be used to explain how one variable impacts another. For example, how does an increase in BMI impacts one blood pressure level? Linear regression will be able to come up with a formula to tell you exactly how much BMI can impact blood pressure levels. On the right here is an example of how simple linear regression functions. This type of regression is limited to one independent and one dependent variable who exhibit a linear relationship, which means as one variable increases or decreases, the other one also increases or decreases. So using statistical software, you can compute a simple linear regression formula, and it will output this formula for you, which includes the y variable, intercept, the slope and error term. The intercept represents the value of the y variable you can expect when your x variable is zero. In some cases, your x variable being equal to 0 does not make sense, so it's a value not really of interest. The slope represents the change in the y variable associated with a 1-unit change in your x variable, and then the error term represents the standard error associated with your model. So there are many tools out there to complete these different types of analysis methods. Excel and Google Sheets are easy tools and easily accessible, and they're really best for computing basic statistics and simple visuals. Although they do have power to compute higher level statistical functions, and we will have an example of that at the end of the slides. But if you have very large data sets or multiple data sets that you're working with, it really is best to use higher power tools like Python, SAS, or R. And as a UNC student, you do have free access to these. If you just look up UNC Python download, it will come up with instructions on how you can download this to your computer. Before we talk about visualization principles, does anyone have any quick questions? And you can just drop those in the chat, I guess. Okay, we can just move on. So, why are visualizations important? Visualizations are how you make your data accessible to your audience. Having poor visualizations can mislead or obscure your findings. If we take a quick look on the graphs on the right, we can see that the top graph shows similar values for products 1 and 2. However, the bottom graph looks like product 2 is significantly less than product 1. Both of these graphs actually contain the same exact data and are suffering from a concept known as truncated axes. The bottom graph axis or y-axis fails to start at the value of 0, which means it stretches its value from 7 to 100, which can lead to misleading results. So some design principles to consider to avoid mistakes like this one is, first and foremost, we keep it simple. Try to avoid any extra elements that don't add anything to what you're trying to convey. Try using consistent color fonts and stick to a basic format. Colors are usually only best when you're trying to highlight a specific point, but really it's not really necessary. Make sure you're labeling everything. This includes titles, captions, your axes, and include units. Always make sure you're using the right scale. And then lastly, make sure you're double checking the data that you're importing into your visuals. So when creating your visuals, it is also important to make sure you use the appropriate ones. Here are some main examples of the common types. So your bar chart is best for comparing categorical data across different categories. For example, differences in average systolic blood pressure between different age groups. Line charts are best for displaying change over time. For example, monthly changes in cholesterol levels. Scatter plots are best when you're trying to show the relationship between two numerical variables. For example, the relationship between BMI and blood pressure. Histograms are best when showing the distribution of a single numerical variable. For example, what is the distribution of exam scores in a class? And then box plots are best when you're trying to show the difference in the entire data range across different categorical groups. This really highlights the data spread, quartiles, and outliers. And a good example of this is what is the income distribution across different job sectors. And then lastly, heat maps are best for visualizing magnitude across multiple variables. This really focuses on correlation, and a good example of this is what is the correlation between different health indicators in a study. So like data analysis, a lot of the same software is really good for creating visuals. Again, as a UNC student, you have free access to all of these and you can download those to your computer. So then the last thing we'll talk about before doing the tutorial is what are the best practices for incorporating your visuals and data analysis into your research submissions or papers or posters? So to me, application publication standards or academic publication standards is important that all your figures and tables include appropriate figure a table numbering. If you're displaying a scatter plot, it is best to name it figure 1, not scatter plot 1, and if it's a table, then you use the word table. You want to make sure you're using titles for tables and captions for figures. They should be brief but descriptive and should highlight what you're trying to convey with your figure. For example, you can title a good title is Figure 1, Scatter Plot showing the relationship between BMI and blood pressure in patients aged 30 to 60. It's also really important to make sure all your axes are clearly labeled and that these axes and labels include units. And lastly, if you're pulling a figure from another source or data, it's really important that you cite it, and it's kind of standard practice to use APA format. On the right here is a good example of how this person incorporated their scatter plots in their paper. They're clearly labeled as figure 2 and they have a descriptive caption. So some important things to avoid when integrating your visuals are not providing an explanation. If you're including a visual in your paper, it's because it contains a point you're trying to convey to your audience. So when you reference the figure, it is important to clearly outline what that message is and why it's important for your research. You don't want to include any figures that you don't reference or reference any figures that don't provide any input into your research. It's also important to not overload your plots with overload your plots, and this includes adding too much data or too many colors or too many formatting issues. You want to make sure that your visuals can be read easily, so you always want to make sure you're double checking your font size or any missing labels. And lastly, like we talked about earlier, you want to make sure you're using the appropriate visuals for the data that you're using, and this can really help you avoid misleading representations. When selecting your visual and when selecting what visuals to include in your research, you want to make sure it has an important point that you're trying to convey, and it's also that it's an appropriate type, like we talked about earlier. And now we are going to do a quick example of how to do descriptive statistics and linear regression in Google Sheets. Roshi, if you can I think in the speaker notes I copied the link.
Yes, let me go ahead and put that in the chat for everyone right now.
Okay, thank you. And then you guys can just make a copy and then follow along.
Is this what you're talking about, Elizabeth?
It's in the speaker notes of slide 17.
Okay, cool.
Yes.
All right, it should be in the chat.
Okay, and then I can start sharing my screen so I can do that, or if you want to just follow what I'm saying.
Yeah, I can go ahead and stop sharing.
Um, I don't think I have permission to share my screen. Or do I?
Here, I can have it shared if it's not working.
Yeah, it's not giving me the option. Okay, can you share the like the Google Sheets? Or like the link that you pasted in the chat.
Yes.
Okay, and then if everyone wants to make a copy, you guys can just follow along the instructions or you can just watch. But on the bottom, I provided two tabs, data and analysis. The data tab just contains a small data set I found online. And then an analysis section includes tables we can fill in and visuals to create. I don't know if Roche, if you just want to like do it while I speak, or I don't know.
Yeah, that works.
Okay. So first, we can calculate mean and standard deviation. Oh yeah, make a copy. Okay, if you go in the analysis tab. Okay, yeah. So I highlighted a research question for us, and it is there a significant relationship between the number of hours of exercise per week and BMI in adults? So a good way to summarize this data would be to calculate the mean and standard deviation of all the numerical variables we created. So to find the mean, we can click on the cell that we want to. So we can just do age for this example. And you're going to want to click the cell and enter the equal sign and start typing in the word average. And then it'll give you the drop down to choose. And then you can, without clicking out of the cell, you're going to want to go to the data tab and highlight all the ages that you want to include in your mean calculation. And then if you click enter, it should compute it for you. Yeah, and then for standard deviation, we can follow the same steps, and the function for that would be STDEV, which just stands for standard deviation, and you can highlight the same row. And then you guys can just do that for all the numerical variables in the data set, and this is just a really good way to summarize your data for your viewers, and again, highlight or just summarize what data you collected and to highlight the entire column, you can just like physically drag your arrow down. And there's also a way, if you know the column numbers, you can just type it.
All right, Lexa, what would you like me to do next?
Okay, yeah, and then you guys should just do this on your own, but you could do that for all numerical variables. And then for the second example, we can create a scatter plot. So to create a scatter plot, we can just go to the top of the Google Sheets and you'll see a function, or it'll say insert like under the title. You can go to chart. Oh, can you do this in the analysis tab? Sorry. Yes, and then for chart type, if you scroll down, you should see scatter plot. Okay, and then to fix the scatter plot to answer a research question, we're going to want our x variable to be the number of exercise per week and our y variable to be the body mass index. And to do this, we can go ahead and click on the bubble for x-axis. And if you click on the 4 cells to the right, you can delete what's already automatically selected and then go back to the data analysis tab and highlight all the values for hours of exercise per week. And then we can do the same thing under series, and in this case, series adds the y values that you're interested in. You can delete the age one. And then we're going to want to do BMI. Okay, perfect. And then that is the data points for x and y variables. We want to, because Google Sheets will automatically edit your graph, you're going to want to customize and write in an appropriate title, label your axes with units. Okay, and then can you drag it under versus scatter plot? Okay, yeah, thank you. And then the last thing we're going to do today is to compute a linear regression for this scatter plot. Can you scroll down? Okay, so when you compute a linear regression in Google Sheets, it will automatically output 8 different values, or is it 10? 10 different values. So I already went ahead and labeled what these values are. So if you click the equal sign in the cell next to slope, if you type in the function for linear regression in Google Sheets is line is, and then it'll give you you're going to input 4 different values. The first is going to be the range of y values. In this case, it's BMI. So we can go back to the data analysis or the data tab and highlight all the BMI values. And you can click enter. Oh. Can you edit the, yeah. And then if you click comma, now you're going to want to go back and highlight all our X values, which for us is hours of exercise per week. And then our last 2 functions are going to be true and true. And what these values do, they just calculate the extra values for simple linear regressions like intercept and regression values. And then this gave us the slope, the standard error for the slope, the coefficient of determination, which is r squared. R squared is a measure of how good the model is a fit. The closer it is to 1, the better it is. So in this specific example, I would say the model is kind of moderate because it's not close to 0, but it's not close to 1. And then for linear regression, F statistic, regression of sum, degrees of freedom, and residual sum of squares are methods or statistics used to compute the p-value. And then if we go back to our scatter plot, we can actually visualize our linear regression by editing it. Yeah, if we click the 3 dots of the chart we already created, and then go to edit chart, and then under customize, we can go under series, and we can check off trend line, and then show r squared, and we should have the same value as below. Do we? Oh, it's a little off. We might have not highlighted all the values. But yeah, the line that shows them the scatter plot is just like a visual representation of the formula we calculated below. And that is often a good figure to include in a lot of research papers. So in this case, our slope is negative 0.877, which just means for every 1 increase in exercise, we see a decrease in BMI by 0.877. Yes, if I didn't write down the 10 value or the 10 labels, it would just return 10 values. And you can just look up Google Sheets function and you can easily find online what these values are, but I just went ahead and filled in what it would output. Yeah, we can calculate the p-value if you guys want to. So under the linear regression formula, in like a random cell below, to find the p-value for this is f.dis. Sorry. No, can you remove? Yeah, sorry. And we were going to use the right tail. No, f.dis.rt. Yeah. And then the x for us would be the f statistics that we calculated in the linear regression formula, which is 21.182. Our first degree of freedom will just be 1 because it's the number of variables minus 1. And then our second degree of freedoms will be 23. And we click enter, that will give us the p-value. So we have a p-value less than 0.05, which just means our model is statistically significant in predicting BMI based on hours of exercise per week. Okay, and then those were just the 3 examples I included for these Google Sheets, unless someone else or if somebody wants to do something specific, we could do that as well. So for linear regression, we have 2 degrees of freedom, and then the first one will just be the number of variables minus 1, and then the second one will be, it's based on the number of observations, but this will calculate it for you. Okay, and now we can just go back to the slides. That's all I have for you guys today. This QR code will log your attendance to receive CLE credit. And then if you guys could fill out this quick Google form, it's like 2.5 questions. But if you guys also have any questions, we could do that really quick.
All right, thank you guys so much for joining. And Lixa, thank you for adjusting in light of all the technical
Yeah,
issues.
sorry about that.
And thank you guys all for your patience. But just as a quick summary and quick follow-up to Lixa's presentation, we are UNC Journey. We are a student-led publication on campus, and we publish student-led research. We are publishing our annual spring publication this coming May. So if you're interested in ever publishing your research or getting involved with us, feel free to check out our website. And if you missed anything from this presentation and you'd like to check it out later, we will be posting a recording of this session on our website. But for anything else, feel free to reach out to us at uncjourney@gmail.com. We'd be happy to answer any questions you guys have. But with that, thank you guys. Have a good evening, and thank you, Lixa, as well.
Wait, someone said in the chat that the QR code is not working.
Okay, if you're having an issue with the QR code, just feel free to email UNC Journey. We'll send you a link where you can manually register your attendance. But
Okay.
yeah, I'll leave this up for a couple more minutes, and feel free to drop any additional questions you guys have in the chat. Me and Lixa will be here to answer your questions. So thank you guys.